John said I'm Mike Small, and I'm an analyst, an industry analyst. I spent my career developing software, and when I retired, I became an analyst and criticized everybody else's software. And the area that I've been working on for the last 15 years is the security of cloud services. And it's interesting to see how these have evolved, because initially organizations were concerned about using the cloud because they were frightened that the cloud provider was not going to secure things. Then they became concerned that they would not comply with the regulations and laws because the cloud provider would not divulge what they did in a way which allowed them to say, we've got full compliance. And then eventually it became clear, as John said, that most of the problems to do with security and compliance with cloud services are actually stem from the failures by the organization to secure the way they use the cloud. And so this is the first challenge. And here are some of the examples that two of them, well, several come from a system called Snowflake, which is a cloud storage system. And effectively, if you had a Toyota car, then all of the telemetry from your car was being held in this. But they didn't secure access to that database using multi-factor authentication. And so if some malefactor could get hold of or steal credentials, then you have access. And once you have access, you're done. Now, that is one of the main reasons why cloud is breached. The second one is a very recent one. This was the 27th of March. A network called Nine Network in Australia. In fact, they lost or had breached a data from an S3 data bucket. And guess what? The S3 data bucket had public access rights, which was clearly wrongly configured by the organization that used it. Now, in fact, actually, it's more complicated than that, because when you look at the cloud, you find that the cloud is a complicated world. And so when you get a data breach, it's almost always due to a combination of problems, that it's very seldom that you simply have an exposed S3 bucket, that somehow or other you have an exposed access to some system which has access rights to something else that has the access rights to the S3 bucket. So these paths to risks are important. And then another wonderful one was that a malware was discovered which exploited the capability of effectively that if you can find an S3, a server within AWS which has access rights to write to an S3 bucket, then it can effectively encrypt it and create effectively a ransomware. But again, the problem was misassigned access rights and lack of multi-factor authentication. So those are the kinds of things that have been causing problems. Now, why is cloud security different? Because, you know, as John said, we've been in this for a long time. Many of the fundamental principles are the same. But there are several factors that make the cloud different. First of all, the resources are ephemeral. Now, when I had a computer that I could sit under my desk, I knew it was there, and it was going to be there for quite a long time. And so once a week, I could run some kind of a scan on it, and I had total control of it. Now, the trouble is that the resources in the cloud can be created on demand. They can exist only for milliseconds, and you don't have time to scan it when it's there. So you have to take a different approach to this. You have to make sure that resources can't be created with vulnerabilities, or you have to have other controls that will deal with that. The second problem is that you're living on a shared infrastructure. Now, we knew that, but the problem is it is not turned out to be that the cloud service provider is the threat. It's the fact that for your assets, for your resources, to know that they belong to you, and for them only to be able to communicate with your other resources within this shared infrastructure, they have to have identity and they have to have entitlements. And somebody has to manage them. And if you don't manage them, then you get problems. And the example of that was the Capital One breach some years ago, where effectively a person had produced a proof of concept which showed how if you could get into an AWS EC2 server that had excessive access rights, then to an S3 bucket, what you could do is you could steal the data from the S3 bucket. And it was the fact that the actual server had the access rights, not the person, it was the server. And this is a problem it's a particular problem in development environments, which is why people use the cloud. Because when you're trying to develop something, you tend to over-permission it to make sure that it works. But when you move into production, then maybe you don't want all of those permissions. The third thing is the scale and complexity. And as I was saying, you know, that an application, a simple application running in the cloud can have hundreds of resources, many containers, many network connectors, many database services all running at the same time. And all of those have to be properly secured. And the problem is that this complexity can be almost impossible to understand. And the paths that you have to risk invariably involve multiple of those elements. And you may not be able to, just simply from thinking about it, work out what could have been the risk from path. Then on top of all of this, most organizations are not using a single cloud. So whereas every one of the major IaaS services and so forth, they all have security tools and security capabilities that do more or less the same things function. They all have different tools with different APIs and different user interfaces and different ways of expressing policies. And so it becomes a nightmare to do it. So, and it's only going to get worse because what's everybody doing with this? They're using it for AI. So now what's happened is that if you want to use AI, the easiest way for you to get going is to go and pay your subscription to one of the cloud service providers, and you buy access to a development environment or to an AI service. And what can this do? Well, one of the first things it can do is it's actually very good at generating code. So I won't say it's perfect because I've used it and it makes all kinds of little errors, but nevertheless, it can accelerate development. And IBM estimated that within the next 5 years, there's going to be 1 billion new apps developed because the AI will facilitate that. And every app is different and every app needs to be secured in its own way. So that's going to add to the complexity. And like I said, it's all based on multiple clouds. So you know, the AI development environment in AWS is different from the one in Google Cloud, which is different from the one that is in Microsoft's Azure. They're all very good, but they're all different. And so you then find that in addition to all of the normal things to do with AI, you've got these technology challenges of, is it being used? And so on. So those are things that are going to make it more difficult. And just when you think you've overcome all of these problems, I couldn't believe this. I don't know. How many of you have to do security training? Well, I do. And guess what? We use a certain organization that does these little online things. And guess what? One of these organizations actually was stung. And what happened was that this is US based. They applied, they offered a job for an AI developer. They went through a series of interviews, video interviews with that person. They did all the background checks and it all came up as real. But the moment that they deployed a Mac workbook to him to work on, the Mac workbook started spewing out malware. So it turned out that he was a complete figment of fake videos, that they had managed to steal a real identity. So they had a real identity with real background behind it, but they were able to convincingly use this generative AI, fake AI system to run credible online interviews and get that far. So this is the kind of level of challenge that if a company that is training in this kind of thing can be taken in, you're going to have to do an awful lot of training to avoid these kinds of problems. So when you then look at the other challenges to do with Gen AI comes with specific security issues, and one of them is training data. Now, in fact, actually, if you wind your way back a step, when I was first looking at the cloud, the thing that organizations were concerned about was shadow IT, cloud services that they knew were being used somewhere, but they didn't know who was using them or whether they were being properly secured. Today, it's shadow AI, because with the cloud, you only need a credit card. You've got a little line of business that thinks I might be able to do something. So they go out and in a rather less than professional way, start to use something. Now, once you put data into these AI systems, it's very difficult to get it back. And so the concern is that you're running something in a general world, in a general service. You've put your private data into it, and the system learns something from that, and it may actually, by mistake, churn it back out to one of your competitors or breach confidentiality. So controlling training data and how it's used, for example, best practice being to anonymize it. Then, which of these services are actually being used? Have you as a company decided which ones you're going to focus on, and how can you control who can use them, at what time and in what way? And so you have the same as you have with your DevOps, you have a pipeline. You know, how do you know that you're using, for example, the appropriate LLMs? Have you introduced a third-party supply chain risk with all of this? And then there are now emerging all kinds of interesting ways in which AI models can be perverted or corrupted or malicious actions taken on them. And done the wrong thing there, right, sorry. And so in effect, what you now need is as well as, or as part of your security posture, you need to include something that covers the AI technology. And what I was trying to say there is some of those things are specific to AI, and some of those are generic in the sense that just like any other cloud service, you need to control which data it uses and which services you're allowed to use. And people aren't necessarily even doing the fundamental things to do with that, never mind making a good job of working out how they're going to defend themselves against the specific risks to do with AI, and it's all related to the cloud. Now, this is an old slide. I only put it in a couple of days ago, and I think you can all understand why I have put that in, because we have seen that, in fact, some years ago, I was talking about the geopolitical risks that you take when you use a cloud service. Now, I don't know, I have people who've told me that you know, the simple answer is what it said, which is that the government and government law always overrides contracts. So if you thought that you were secure in the way you use the cloud because you've made a contract with a cloud service provider that is in a different jurisdiction, you may not be as well protected as you might otherwise think. Now, first of all of the cloud service providers in the major ones all have European accredited contracts, and you can ask for European approved clauses to put in it. But force majeure, the government can always override them. A government can go to a citizen and say, I require you to do this. And it's legal for them to do it. So you have a problem of sovereignty. And if you live in a world where a president can sign a piece of paper effectively declaring war on another jurisdiction, then how confident can you be that the service that you're receiving from them is in fact going to be continuous, going to be secure, and going to be confidential in terms of the way that it uses your data? And there are 4 areas of sovereignty. And the first one, which everybody got upset about and excited about with GDPR, was data sovereignty. And with GDPR, there was these arguments, Maximilian Schrems, who has waged war continuously against Facebook to do with its use of data and so forth. So one of the problems is, where does your data reside, and can somebody else access it through a legal intercept order from a foreign government? And so if you put your data into the cloud, you're taking that risk. Now, to be fair, nearly all of the 3 major cloud service providers have an answer to all of these things. And they will say, well, we can say to you, you can force your data to reside in Germany, say. You can require that the administrators are German citizens, and you can require that the physical location and the physical infrastructure can be held and owned by a German company. So that takes you on to the operational sovereignty. And so that was related to this data sovereignty in the sense that if the administrators were US citizens and they were required by a US government to use their administrative access to get at the service to steal your data, they could do, and they would have to, and it would be legal. Now, in fact, again, most of the cloud service providers will tell you the controls they have against it. For example, in AWS, they have these things called the Nitro servers, and the Nitro service has a control plane which is physically separated from the actual data plane that is used by the system. So they claim the administrators cannot do what was said there. This is perhaps one of the most worrying things, which is technology sovereignty. Now, I worked for an American software company, and one of the things that they were really, really paranoid about was people using their software without paying. So licensing or use of software without permission is something that is well developed. And so even if you think that this service is being run in a box that you've got in your offices, is there a key in it that a government could turn off to stop you from using it? Do you think you can run an Oracle database in Russia? Well, I'm told from a very good authority, you won't be able to. So even if all of these other things, if you depend upon the infrastructure stack in one of these big cloud service providers, and a certain president said, under no circumstance this can be run in England, you might find yourself with a problem. And then, in a sense, we've talked about this, which is where is it all physically located? Now, these are risks. Then I'm not saying they are at the top of mind, but in my, and for some time I've talked about these, but I think they are risks that every organization needs to think about. And what often is the case is that today's friend can become tomorrow's enemy. And like every risk, you have to make a judgment about them, and you have to decide what you're going to do. Now, I don't have an answer in this presentation to this, and I wouldn't have put it in were it not for the rather bizarre things that have happened over the last few weeks. Now, so the result of those challenges that I started off with is that a market has grown up in what I would call cloud alphabet soup. That every one of the cloud security problems that you can think of, there is a tool for, and that tool has an acronym. And it could be cloud infrastructure entitlement management, it could be cloud workload protection platforms, it could be cloud native application protection platforms, and so on. And the problem is that this has come from a model of how you secure the cloud, which has been focused on one of the main risks, which is to do with how you develop software. And it's interesting because, in a sense, when you're using the cloud, everything's data. You know, you used to have a physical server, but you don't now. What you have is a server which is described as a piece of infrastructure as code. And its permissions and everything are to do with code or data. And so if there are going to be vulnerabilities in it, those vulnerabilities are actually in that data. You've not configured, you've not written the code, it contains errors that are well known. You've not configured your structure of your infrastructure without leaving unwanted holes. Then you have a process which is called the build process, the deployment and integration pipeline, the CI/CD pipeline. And so in that build process, things can go wrong because you can say, well, I didn't actually bring, I didn't write all of this code. I'm using some open source, or I'm using a common tool like the various tools that we have seen that you know everybody's using. It's maintained by one guy in Alaska, and it has a hole in it, and suddenly everybody discovers it. So when you build that up, when you use external things, you introduce third-party supply chain risks, and you need, in the world that I've been describing, you need to be able to prevent these things from getting into production. So you need to secure it as it is being built. And then when it gets into the cloud, it becomes part of this ecosystem that may include other things that are owned by the company, but which are part of your organization's use. And so you need to be able to keep it secure when it's running, and things will change. And so, for example, how are you going to make sure that the things that you have deployed are not changing? How they're not calling what is called drift. They're not drifting. People either they are being interfered with by some third party to add problems. And then finally, when it is running, you need to be able to detect problems. And when you find a security problem in what is running, then guess what? You've actually got to go back and change the data. And so this has become called code to cloud and cloud to code, because the disconnect has been between the security teams, which were traditionally engaged in securing infrastructure, and the development teams, which were traditionally involved in creating code. And you have to involve the whole circle of people in all of this. And in response to that, you've got at least these different things, which is my cloud alphabet soup. So we need to get away from that. And just to give you an interesting little take here. Now, again, this was a paid-for study by a company called Palo Alto that partnered with IBM. And IBM has a thing called the Institute for Business Value. And so in a way, these are serious people, but they studied the number of security tools that, the average large vendor was having. And they found that on the average, they had 83 tools from 29 different vendors. Now, that is a disaster waiting to happen. And certainly complexity is the enemy of security. And the problem with cloud is that when you deploy this application with hundreds of elements in it, it's complex. And things that are complex are very hard to secure. And if you have to have all of these different tools in order to do something, then it's kind of squaring the complexity. And interestingly, one of the things which I can't verify, but they in that business study, it's worth reading, is they actually make a claim that if you were to reduce that complexity and you could get it down to using what they call a platform, then they make a claim that organizations that are using a single platform for security make a saving of 5%. 5% of what? 5% of the total turnover of the organization, which is quite an astounding claim. So I'm not saying it's true. I'm simply saying, please read it and make your own mind. Now, so as a result of all of this got me to sit down and say, well, what are the pillars of cloud security? This is also complex. How can you try and bring it together? How can you create what you might call a security fabric, which will do what you need and give you the simplicity? And so I basically postulated that there are 4 real areas that you need to focus on. And these are shown here. First of all, you have to remember that security is shared between you and the cloud service provider. then the most common reason for breaches to do with clouds come down to identity-related problems. And in fact, the thing that people are most concerned about in the cloud is the security of their data. That's one of the things that everybody is concerned about: the loss of intellectual property, the failures to do with loss of compliance because of data privacy. And then the other big risk that organizations are faced with is the fact we've now digitalized. If we lose the service, we are off the air. The business no longer runs. And that means that you have to have a way of being resilient to the cyber threats that are constantly attacking. And so let's take some of those at a time. First of all, there is, and some of you that have been in the auditing area will understand what I mean here, that clearly the responsibility for security is divided between you as the user and the cloud service provider. And interestingly, when one of these cloud services comes to you and says, hey, we've got a SOC 2. Yeah, well, what does that SOC 2 include? One of the things it includes is whether or not the service contains controls which the user can use to secure their use of the service. And those have this wonderful acronym that only, computer auditors can think of, which is Complementary User Entity Controls, CUECs. So they have to provide that, and it's your responsibility to implement them. And it's their responsibility to do this. So it's your responsibility to implement the controls that you need. And you need to ensure that. But in order to overcome and the concerns and problems I talked about earlier on, together with, is the cloud service provider telling you a good story? You need to assure the service. Does the service meet your requirements, and how can you tell? Well, basically, from the perspective of technology, audits and design and things like this are elements which are the best indicators of that. Contracts are not very good because contracts usually were written by the cloud service provider and basically don't give you much recompense if it all goes wrong. But you need to understand that. And what we're going to talk about now are these complementary user entity controls. Now, where should you look for these controls? Well, first of all, the point is that they're well published. There is, for example, this thing called a MITRE attack matrix, MITRE defend matrix. So my suggestion is that what you should do is start off by saying you're going to use the knowledge that people have already gathered, and you should be looking to implement that knowledge. Now, certainly the bad guys, they share for a price, they share what they have learned, and they make money out of it. And we need, as the good guys, to use the things that we've got. And one of these things is, in fact, artificial intelligence. Now, the threat actors are already using and exploiting Gen AI. They are using this to write better spam emails. They're using this to modify malware, to create better malware, to modify it. They're using it to reduce the time it takes them to break in from days down to minutes. They're using them to increase the effectiveness of their attack techniques. So it's really important that, as well as using the knowledge we have through things like MITRE and attack, that we're exploiting the AI and machine learning capabilities that are now available to improve our controls and improve our tools. So I'm going to just talk shortly for each of these things. Now, there's lots and lots of pictures about identity. You know, the 4 A's: authentication, authorization, administration, and audit. So I could have put those forward. But why didn't I? Well, the ones that I put up there are the ones which, if you look at the MITRE attack framework, these are the ones that come up most often as being the defense against the kinds of threats that we have seen. That the threats come, the risks come from places where there has been a lack of enforcement of least privilege. You know, you've given too many administrative privileges out. You've over-privileged a machine. You've over-privileged a user. The thing that really comes out time and again is the need for strong authentication. That even with strong authentication, there are problems, but basically, if you just use username and passwords for anything that is in any way sensitive, gives any kind of important access, then it will have been stolen. Somebody will have stolen your username and password. So multi-factor authentication, or even better, things like passkeys are a much better thing. You should not be having any kinds of administrators or administrative accounts which use anything other than strong authentication. User behavior is an incredibly good indicator of compromise. And it's one of the areas where Gen AI or machine learning is really good at seeing unusual behavior. And Microsoft, for example, they used that to detect rogue attempts to log in. I mean, you know, they have this enormous sort of worldwide suite of Office, and everybody's trying to get into it. And they found that by putting AI on this, they were able to detect the patterns of behavior which they hadn't even thought of. So if you then say, well, how does an attacker actually work once they get in? The first thing they try to do is to, whatever privilege they've got, they want to get more. So they start to look to see how they can escalate that privilege. So you should be looking to detect escalations of privilege. And that is effectively rogue accounts. Now, rogue accounts are ones that are behaving in an abnormal way or are a risk because they are no longer being used or they no longer have an owner. And that takes you on to the need for account reviews. And don't forget, in what I was talking about, that one of the big areas is non-human identities now, which is all of these elements in your service that have identity, not to mention the zero trust, which is the identity of the devices, and in operational security, the identity of your machines. Now, I'm not going to dwell upon this, but I mapped those things against the MITRE attack tactics, and you can see how, without looking in detail, you can look at the density of the arrows or the ticks. So in the interest of time, I'm going to move on. Now, data-centric security is taking the same kind of view if we look at data. And if you say, well, if you go through the MITRE and attack tactics and look at the catalogue of the most effective ways of dealing with those, you come up with this. that first of all, you can't protect what you don't know you have. So data classification is really, really the fundamental foundation of data security. Then in the cloud, the problem that is the recurrent theme is the fact that people have publicly accessible stores with data in them, which you can create. You can create an S3 bucket, you can create a database service, and you can over-privilege it and over-permission it and connect it directly to the internet. So actually just making sure that you have a policy that goes around and removes or controls wherever you've got public access. Then encryption in its various forms is important. And there are multiple forms of encryption. The simplest one being the symmetric encryption, if you will, that we're all used to. If you look at data in transit, you also need to think about that is invariably protected by things like certificates. And the problem with that is that they are asymmetric. And we now know that there is this nascent threat that's coming down the highway to hit us, which is the so-called post-quantum problem. And so you should already be planning for how you are going to deal with the risks posed by post-quantum cryptography. For data that you want to use for training, it is generally becoming accepted that the best way of protecting that is to use the right kind of pseudonymization. And the NISA has written various papers on what that might be, but it turns out you can train AI models on pseudonymized data, and it all works. And in that way, you don't have to expose that data in a way which could be threatening. The confidential computing is part of all of this. And this is an emerging area, but at the moment, the most practical solution to that is what are called enclaves, where you process things within protected pieces of hardware if you are concerned about the theft of data during processing. Another area is either unintended or malicious leakage of data by employees using non-structured office tools. And there are tools which can help you to prevent that, called data leakage prevention, which in one way or another deal with people sending things by deliberately or by mistake and trying to exfiltrate them from the organization. And don't forget, you need to back it all up. And if you don't believe me, then a couple of years ago, there was a French cloud service provider called OVH Cloud, and there was a fire. They had 4 data centers on a campus, and they said, everything is fantastically well separated. They're all in different buildings. They had a fire. And it was in the middle of COVID. And the allegation, which I don't know whether it's true or not, was that it was due to somebody dropping a cigarette butt into a bin full of masks. Anyway, this set on fire. It's a good story anyway. So this set on fire and it started to spread into one of the buildings. The fire service came down and they said, yeah, we've got to put this out. But there's electric in there. We're not spraying our hoses on while there's electric on. Where's the power? And the substation was there, the substation, which fed all 4 data centers. So they turned it off. And I think it only took them about 3 or 4 weeks to get the whole thing back. And there was a lot of people who had their business data in there. And, well, it's a cloud. So it must be secure. We don't need to back it up. So don't forget about data backup. And if you have a plan, if you have a data backup, have a plan and test it. Have this plan for how you're going to recover. And well, we only need to look just a few miles down west about recovery plans. And everything went to plan. Well, the CEO told us. So once again, and I will let you have a copy of these slides. Once again, I've done a matrix of this.
They'll all be available online, Mike.
Yes, I'm going to send you a PDF or whatever. And so the final one is the threat resilience. And it's interesting in a sense, this applies to all of them. But the first and most fundamental thing is the first line of defense is your users. And you need to train them. And you need to train them to be bloody suspicious. Basically. Because it's getting worse, and with deep fakes, it's getting even worse. I mean, I had a conversation with my bank. The bank said to me, we want to speak to you over the phone, and we're going to send you a Teams link. And I said, how do I know it's going to be you? Well, with a bank. So having just thought all this about deep fakes and everything, how do you know? So, well, what I did, and I confused them all, because I rang the bank number that was on my card. And I said to them, there's somebody has told me that they're going to speak to me. And they said, and I'm, oh, yes, that's the right name. Oh, yes, it's the right name, but is it the person? So I am going to give you a word. And I want you, using your internal bank secure communication, to say to me that I will only believe this Teams meeting when that person says this word to me. And they said, nobody's ever asked that before. So this is a problem. This is a problem. So I've been on course, you see. So all of these things are the things that you will have traditionally learned as being the elements of security. And they're still the elements inside the cloud. It's just that they slightly change. That network security also involves the connection from you to the cloud service. But within the cloud service, there are all these routers and virtual network devices which need to be configured properly. And you're going to have to set up a network in there because the threat actors are going to try and do lateral movement. They are going to try and get into one place and try and get to another. So you need to make sure that that is properly configured. In addition to all of the problems that you knew existed with servers, like not patching the operating system, making root available, and so on and so forth, you now have the fact that the compute server itself has permissions. And so you've got to manage the permissions of the compute server. You've got to find if it's being over-permissioned, if it's not being used, and has it got an owner, and so forth. The whole of your development control and pipeline and whatnot is going to be in there, and you need to secure the use of these services, because within all the various clouds, rather than you having to run your own Kubernetes service, there is AKS for Amazon, EKS for another one, and GKS for Google. And you need to manage all of those. Then you've got this added problem, which is there's now people using these Gen AI services and the data that's associated with them. And all of that is churning away. And so you need what used to be called, or being called, extended detection and response running inside the cloud. First of all, to make sure that everything is configured so that when one of these virtual devices is instantiated, it is correctly configured. and that you have a way of checking that the configuration doesn't drift and it remains the same. And then when things are running, you need to be able to detect and respond to what's happening. And once again, I've got a matrix which I filled up. So to finish off, what I've been basically saying to you is that cloud security is the same but more complex. It's got new dimensions to it, and those dimensions are to do with the ephemeral nature, the fact that it's data defined, and it's extremely complex. And what you need is a common and consistent way of thinking about security, which is based on remembering that you are responsible for securing your use of the cloud, that identity and access management is the most critical and the fundamental defense that you have as a preventative defense, that data security matters because your data is what is probably the most valuable thing to you, and you need to prevent problems by making sure you protect that data using common, well-known techniques like encryption. And finally, when it's all running, you need to make sure that you are monitoring it and responding, and that the response is from code to cloud, and from cloud to code, and that leads you to this. So that basically is my tale. So thank you very much. And I'll have some questions now.
Thanks, Mike. I'm going to use my privilege of being chairman of this group to make two observations. The first one relates to the whole problem of cloud security. It reminds me of that very famous textbook, Hitchhiker's Guide to the Galaxy, which is one of the best reads you can have for security, where you find out the whole universe is just an algorithm run by mice. And the second thing is, one of my banking colleagues, his bank uses a concept, my voice is my password. You can't believe how stupid they can be. With all this generative AI about, all this deep fake stuff, my voice is my password. It's absolutely incredible they're so bad about it. Mm. So that aside, just my two observations there. Do you have any questions from the audience here?
I've got a remark. I just thought that was brilliant. That was really comprehensive and, you know, mind-blowing. And you kind of want to, partly you want to go back home and just pull the duvet over your head.
Tear everything up, yes.
All sorts
Go
of
back
things
up
that you
to
pull
your
together.
server and nothing else.
Well,
Yes.
let me make a suggestion then. Instead of doing that, come to our conference in Berlin. Which would definitely worth coming to. Berlin's a nice city. But thank you.
Thank you very much.
I can't find anything here. So we'll assume that there are no online questions. Okay, before we depart, and thank you very much, Mike. That really.
There is one online question, John.
Oh, go ahead, Manuel.
Okay, it's from Stevens. Yeah, he said, "Thanks, Mike. Where does security testing fit into this model, or is it woven into all four pillars as it is now?" So I go over. It says, "Where does security testing fit into this model, or is it woven into all four pillars as it is now?"
Well, security testing, one of the things that you should be doing as if you're a large user of the cloud with your own applications is in fact inviting an appropriately qualified security testers to look at your cloud from outside, look at your applications in the cloud from outside, to check whether or not there are any obvious errors and loopholes. So yes, in all of this, there are areas where you can do security testing. Now, in fact, in development and pipeline, there are now tools that you would expect. For example, static code testing tools to help you to do this, and also sandboxes and dynamic environments to check for this, to check your code for common common vulnerabilities. And once again, you may wish to employ people to do that. But the most obvious thing is the external assessment of your security posture as seen by an outsider from the public cloud. So yes, it fits in.
Okay, just before we.
Thank you. There's one more question, please. I don't know whether, I think two more. I don't know whether there's enough time. But
Okay, Emmanuel, carry on.
two more questions have come in, so kindly bear with me. Yeah, the first one is from Cheryl. He said, no, it's from Eric. He said, which pillar would the validity or genuineness of data and sources fall into? And the second one is from Mick, who asks, how can we secure SaaS solutions where we subscribe but have no visibility? So these are the two main questions now.
Oh, okay, so the first one was to do with data provenance. And in a sense, data provenance is a problem, but data provenance was usually seen as a data management problem. And it does have a security implication. And it was very obvious when GDPR came out, how many organizations were using personal data which they'd obtained from dubious sources. So it's one of these areas that it has security implications. I mentioned in the Gen AI, do you use personal data for training? And if so, there's a risk that that would effectively leak out and be used. So it has security implications, but basically data provenance is fundamentally a problem of data management to make sure that the data you use is valid. Now, the second problem was, I think, software as a service.
What was the second one, please, Emmanuel?
Software as a service security.
How do you secure it if you don't have any
You
visibility?
can't see it. You have to secure it if you can't see it.
Sorry,
How do you secure it if you can't see it?
how do you secure it?
If you have software as a service, if you have I don't know, Salesforce, whatever, how do you secure it?
So yeah,
Yeah.
okay. So if you're using Salesforce or you're using that, your responsibilities are to control access to that service and to make sure that the data you have is properly protected. So that's your responsibility. Now, how do you make sure that the service provider is doing what they're supposed to do? And this is what I alluded to at the beginning, that you ensure that you secure things and you have to assure the cloud service provider's service. And the assurance you can get can come in various forms. You can say, I have a contract, which isn't very good. You can say that I've got independent certification of the service, which is better. And all of the big software as a service providers will give you SOC 2 and other compliance reports. And the final thing is to do, well, is to do with having visibility of the way the service was constructed. And so, in a sense, the strongest thing is to have engagement and proof of the service provider to show you how they built the service. Now, most of the software as a service providers won't generally do that, but they may do it if you're in a regulated industry and they really want your business. And so, for example, one of the major service providers has a big business in the financial industry, and they've started to produce a cloud service which is financial services industry certified, in the sense that they have declared in a private way and exposed what they do to the industry regulators, so the industry regulators can, if you will, add their own level of attestation to say that this use of this cloud service is in fact satisfactory and compliant with your duties as a financial services organization.